Hey guys, R4GE VipeRzZ here, and today I'm going to show you how you can set up a home VPN using a Raspberry Pi. So you should be able to do this with any Raspberry Pi that can run Raspberry Pi OS and has an Ethernet port. In theory you can also do this with Wi-Fi only ones, but I wouldn't recommend that, and it would require a different configuration. So I do not recommend that. I do recommend you use one that has an Ethernet port. So the first thing we need to do is we just need to come to the Raspberry Pi website and we need to download Raspberry Pi OS. So we're going to be using the Raspberry Pi OS Lite, so we'll just download that. If you want, you can use the Raspberry Pi installer, but instead we're going to be using Rufus. So we'll just download Rufus, and whilst that's downloading, we will also download PuTTY, as we're going to be using that to SSH to the Raspberry Pi. You don't have to SSH, it just makes it easy to get to it remotely over your local network, and you don't have to use PuTTY, you could use any other SSH client that you would like. I'm just going to download that. So for our home VPN, we're going to be using Tailscale. So with Tailscale set up, any devices that are ready to our Tailnet will be able to connect through to our Raspberry Pi and then exit out of the Raspberry Pi. So your Raspberry Pi will be located at home, and then from a device that is part of your Tailnet anywhere else in the world, you can connect through to your Raspberry Pi and then exit from there. So it is as though you are at home. So now all those things I've downloaded, if we now come to File Explorer, as you can see I already have the SD card from the Raspberry Pi plugged in, so we now just need to put Raspberry Pi OS on it. So if I come to our downloads, and then I'll just export the IMG file, and there we go, that is now extracted. So I will now open Rufus up, and then I'll make sure that the SD card is selected in the devices, as whatever device is selected here will get wiped when we start the process. So if it's not the correct one, change it, make sure you do have the correct device selected. And then after that we'll click select, and we'll then select the Raspberry Pi OS image. And now we've done that, we'll now click start, and then we'll click OK, that we know data will be destroyed off it, and there we go, it's now starting to write the image. Now for the Raspberry Pi, it is going to want to be on a static IP address, so that isn't just an address on your local network that isn't going to change over time, it will always be on that specific address. Now the best way to do that is through DHCP on your router, and that is what I have done for my Raspberry Pi that I'm going to be setting up. Now I won't show you how to do that, as that does change between your routers, and you'll need to figure out how to do it for yourself. Now you can also statically set an IP on the Raspberry Pi itself, however that's not always the best option, as if you don't change your DHCP scope, you could get devices trying to get the same IP as your Raspberry Pi, but you can do that, and I'll show you how you can set a static IP if you really want to. But there we go, that's now finished writing, so if we close that down, I will just go and get the SD card on my computer, and I'll plug it into the Raspberry Pi, and then I'll power it up and join you back when I've done that. So there we go, the Raspberry Pi is now booting up, and now the first thing we need to do is we need to enter a username. So I'll just enter a username, and then I'll enter a password, and then I'll retype the password, and then I'll now log into the user that I created. And then the first thing we need to do is we just need to set our local configuration. So to do that we will do sudo raspi-config, and then press enter, and then we'll type our user's password. And for me, the only thing I need to come in to do is to go to localization options, and then WLAN country. Again, I don't really need to do that, it's just to stop it warning me saying it's not set. However, depending on where you are in the world, you may have to do more regionalization options. So there we go, I've now selected that. So now I can come down here, go right, and then press finish. And now the next thing we need to do is we just need to type sudo space apt space update, and then press enter, just to update our repositories. And then we just need to run sudo space apt space upgrade space -y, and then press enter to apply the upgrades. So if you do want to set a static IP just on the Raspberry Pi itself rather than through DHCP, even though I don't recommend it, this is how you can do it. So you would type sudo space nano space /etc/etc/dhcpcd.conf, and then press enter. Then you want to come down to the bottom here, and then you would want to type interface space eth0 for our Ethernet port, then come down the line and type static IP underscore address equals, and then the IP address that you want the Raspberry Pi to have. So in most cases that would be something like 192.168.1. and then some address, so say let's go for 10, and then you'd want to end that with /24. So that needs to be an address on your network that isn't currently in use and won't be used by other devices. And then you want to press enter and do another static, and then type routers equals, and then the IP address of your router. So that in most cases will be 192.168.1.1, and then you want to press enter and do static space domain underscore name underscore servers equals, and then the IP address of your domain name server. So again, in most cases that would be your router, however you may have it set up slightly differently. but in most cases it would be 192.168.1.1. Then to save those changes, all you would do is press Ctrl and X, then say yes to saving them, and then press Enter to commit them. But as I've set IP through DHCP, I do not want to apply these changes, so I'm going to press No. So now we've gone over that, the first thing we're going to do is we're going to set up unattended upgrades so that you don't have to keep going onto your Raspberry Pi and updating it. We want it to update itself to any latest security patches, and we can also make it just apply all updates no matter what. However, applying all updates no matter what does bring a larger risk that there is going to be something to break it, so it is up to you what you want to do. So to do that, we're going to type sudo space apt space install space unattended dash upgrades space apt equals list changes space dash y, and then press enter. And I've put a slight typo there, it is unattended upgrades. So if we now press enter again, as you can see, it's now installing. And now we've done that, we now just want to type sudo space dpkg-reconfigure dash priority equals low space unattended dash upgrades, and then press enter, and then say yes on that. Now we just want to type sudo space nano space /etc/apt/apt.conf.d /20 auto-upgrades, and then press enter. So the first line here is just saying for it to refresh available updates every day. The second line is to say to install updates automatically every day. And then we're going to add a third line here. So we're going to type apt::periodic: AutocleanInterval space speechmark 7 speechmark semicolon. So that will just tell it to remove old install files every 7 days. So if we now press Ctrl and X to exit, and say yes to saving the changes and press enter to commit them, the next thing we need to do is we just need to type sudo space nano space /etc/apt.conf.d /50 unattended-upgrades, and then press enter. And that should not be blank, so I must have put a typo, so I'll press Ctrl and X, and then up to have a look at the command again. And that is why, because I put etc/apt.conf.d, and it should be /etc/apt/ like so. So if we now press enter again, and I've also gone and missed a D in unattended. So if I now press enter again, as you can see this time now I've spelled the command correctly. So by default, these options here are now uncommented, which will mean it will install security updates automatically. So if you only want to do security updates which are the most stable, then leave it as so. If you want to install all updates that are available, you just want to do the following. So I will come out to, and then go back to, and then do // to comment it out, then go up another line, backspace, then // then again up a line, backspace, // and then we'll come up like so, and we'll create a new line, then we'll press tab to keep it in line, and we'll then type speechmark origin equals, then start, then speechmark, and then a semicolon on the end. So that will now mean it will just install all updates. Now the next thing we need to do is we need to come down until we find where we can allow it to auto reboot if necessary. So there we go, at this line here where it says unattended upgrade automatic reboot, we want to come and uncomment this line, so get rid of the 2 /, and then we want to change it from false to true, so that if it does need to be able to reboot after an update, then it can do. Now we also want to come down to where it says unattended upgrades automatic reboot time, and we want to uncomment that by getting rid of the 2 /, and then you want to set the time that you would like it to reboot at if it does need to reboot. So by default it's at 2 o'clock in the morning, I'm going to change it to 5 o'clock in the morning. You can set it to whatever you would like, and then once you've done that you want to press Ctrl and X to exit, say yes, and then press enter to commit it. Now the next thing I'm going to do is I'm going to enable SSH. Again, you don't need to do this if you don't want to, but this will mean I can just remotely get to it from my other computer on the local network. So to enable it, we're going to type sudo space systemctl space enable space SSH, and then we'll just type sudo systemctl space start SSH, and then we'll type sudo space systemctl space status space SSH. And as you can see, it's now actively running. So I'll now switch back over to my Windows machine, SSH in, and then continue from there. So I'll go do that. So now we're back over on the Windows machine. I'll first just install PuTTY, and then if I open PuTTY up, and then I just type the IP address of my Raspberry Pi, and then I'll just accept the warning, and then I'll just make it full screen, and then I just need to log in again. So I'll just type my user's credentials. And now I've done that, we now just need to carry on with some more of our rules. So we now just need to implement an allow traffic rule to allow the forwarding of traffic coming in. So any device that sends it to the Raspberry Pi, it then needs to be able to change the IP address of the requester to the Raspberry Pi so that when it's sent out again, it appears to be coming from the Raspberry Pi. So to do that, we will type sudo space nano space /etc/ctl.d/99-ip-forward.conf and then press enter, and then we just need to type net.ipv4.ip_forward space equals space 1. Now if you also want to use IPv6, then you just want to type net.ipv6.conf.all.forwarding space equals space 1. Now I'm not going to be using IPv6, instead I'm going to be disabling it just to make it simpler if I ever have to troubleshoot, and because I do not need IPv6 to work. So to disable IPv6, if you do not want to use it, you instead want to type net.ipv6.conf.all.disable_IPv6 space equals space 1. And then you also need to type net.ipv6.conf.default.disable_IPv6 space equals space 1, and then net.ipv6.conf.lo.disable_IPv6 space equals space 1. So there we are. Now we've typed that, we're just going to press Ctrl and X to exit, say yes, and then commit the changes. Now we're also going to implement some traffic forwarding rules using IP tables. However, these aren't necessarily needed. Tailscale should implement its own rules that mean these aren't required, but this is a good backstop to add. So to do that, we're going to type sudo space apt space install space ip tables -persistent space -y and then press enter. And there we go, it's now installing, so we'll say yes to that and yes to that. And then we just want to type sudo space ip tables space -t space nat space -a space post routing space -o space then eth0 for our Ethernet adapter, then space -j, then space masquerade. And then if we press enter, and then we do sudo space net filter -persistent space save, and then press enter. And now we've got our routing sorted. We now need to install Tailscale and bring it up. So to do that, we will type curl space -fssl space https://tailscale.com/install.sh space pipe space sh, and then press enter. And that will now install Tailscale. And there we go, Tailscale is now installed, so we now just need to configure it. So to do that, we'll type sudo space Tailscale space up, and now we just need to decide on the things that we want to advertise. So if you just want it to act as a VPN, we just need to be able to advertise it as an exit node. However, if you want it to work as a VPN and also allow access to local devices on your network whilst going through the VPN, then we'll also need to advertise its routes. Now, if you're not sure, you probably don't want to advertise routes. Only advertise routes if you know you do want to be able to get to other devices on your local network through the VPN. If you don't, do not advertise routes. So we're just going to type --advertise -exit -node as we want this device to be used as an exit node. Then I'm going to type space --advertise -routes equals, and then you want to type the address of your local network. So for me that is 192.168.1.0/24. That would most likely be the same for you if you were using a 192.168.1 subnet. Again, if you do not want to route to local devices on your LAN through it, do not set that. Then you want to do space --accept -DNS equals false, as we don't want the Raspberry Pi to be trying to go to Tailscale for its DNS, as it's going to be acting as an exit node, so we want to tell it do not do that. And then we want to do space --snat -subnet -routes equals true, and then just in case you've accidentally set any other settings, we're just going to do --reset on the end. So now if we press enter, as you can see that has now succeeded, and we now need to go to this address here that is given us to add the device onto our tailnet. This will be a unique URL for each time that this is ran. So as I've SSH'd the machine, I'm just going to copy this address, and I shouldn't have pressed Ctrl and C there as that's cancelled it, so I'll just go up and run the command again, and then I'll select the address again, and this time I won't cancel the command. So if I now come back to the browser, and I paste the URL in, you can just type it out if you do not want to copy it between, and then you just want to sign into your Tailscale account, and then we just want to connect to the device up. So there we go, it's successfully connected. If we check back on our Raspberry Pi, as you can see that was successful. And if on Tailscale we then come to the admin console, as you can see the device has been added on. Now the first thing we're going to do is we're going to click the three dots and then we're going to disable the key expiry just so it doesn't expire over time. If you want to mess about with keys, you can do. Then the next thing we need to do is click on the three dots again, and then you want to click on edit root settings. Then you want to select the use as an exit node option, and if you did advertise subnet routes, then you also want to check that box as well, and then click save. Now this is the name that will show up to the rest of your tailnet, so if you want to name it something else, you can do by clicking the three dots, then clicking edit machine name, turning off the auto generated one, and then type in a name. So if I just call it VPN, and then update the name, now all users on the tailnet will see the exit node as being named VPN. So now we've done that configuration there, we're now going to come back to the Raspberry Pi, and we now need to ensure that Tailscale will start on boot. So if it restarts at any point, Tailscale will get started back up. So to do that, we'll do sudo space system ctl space enable space tailscale d, and then press enter. And then we'll do sudo system ctl edit tailscale d, and then inside here we'll type after equals network dash online dot target, and then we'll press enter and we'll type once equals network dash online dot target, and then we'll press Ctrl and X to exit, say yes, and then press enter. So that just basically makes sure that Tailscale will only start up once the network has been established. If you don't do that, then you could end up in some weird situations where Tailscale starts up before your network interfaces come up, and then Tailscale won't work properly. So if we do that, we then shouldn't run into that option. So now we've done that, we will just reboot the Raspberry Pi and make sure it all works. So we'll do sudo space reboot and then press enter. And now I've given it a bit of time to reboot, I'll just check that I can reconnect back to it. And there we go, as you can see I can now connect back to it, so it has restarted. So just to test it, I have Tailscale installed on this machine as well. It's not the best example as this is on my same network, but it will show you how to use it. So on a Windows device, it should open up in the taskbar. So if we right click on it and then we click login, and then we just connect it up. So this is adding now the computer to our tailnet. So again, as you can see, the desktop has been added on. And like before, I would recommend clicking the three dots and disabling the key expiry just so it doesn't fall off. And now if we come back to the taskbar and we right click again, we can now come to exit nodes, and as you can see the VPN is an option. So by default it will be on none, so it won't be getting routed through your VPN. But if you then select your VPN, so now all of the traffic on this computer will now get sent to our tailnet, and it will then exit out of the Raspberry Pi. So if this computer was located somewhere else in the world, it would appear as though we were at home. And let's just check that the internet is working. So there we go, as you can see the internet is working, and it will now be routing all of the traffic from this machine out through the Raspberry Pi. So guys, hopefully that worked for you. If you liked the video, don't forget the like button. If you disliked it, hit the dislike button, subscribe for more content like this, and I'll see you another time. Bye.